Hi, it's Moser with a little conversation about mixtures and chemical purity. So, let's say someone gave you a beaker with a pure substance in it. Don't know what the pure substance is, but it's all this white stuff. Great, you got a pure substance. Or do you? So, let's talk about contamination. We can expand our image here, and if we look closely, sure enough, we see that with all this little white stuff, we have a few little tiny red specks. They're hard to see. What are they? Well, we don't know. Do they matter? We don't know. It all depends on what we're going to do with this pure substance. If you ever get a chance to go to a salt mine, a literal mine, a hole in the earth where they are digging salt up. How cool is that? This is salt that condensed out of ancient oceans and laid down big, thick deposits, in some cases tens of meters of thick, of just salt. Oh, salt and, ancient fish poop and mud and, the bodies of dead insects, all that stuff. But it's salt. Is it pure salt? Well, look at the color of this salt. It's kind of brown. Ugh. There's a mine on Lake Erie where they actually dig this stuff up from underneath the lake. Yes, you can travel down a mile under Lake Erie and go into a tunnel full of salt that's been mined, and they don't purify it at all. They don't separate the salt from the other components, the bug guts and the fish poop and all that stuff. They leave it unpurified, and it's just fine, because you know what that salt is used for the most part? Putting on the road so the ice melts. It doesn't matter if there's ancient fish poop and bug guts and mud in that rock salt. It's going on the road and you're going to drive on it. It doesn't have to be very pure. Now, what if you wanted to eat it? You might want something that's been cleaned up a little bit more. This right here, this is also salt. It's just salt that's had the fish poop and the dead bugs and the mud removed. It's been purified. It's been separated from those components using a physical separation process. Well, that's easy enough. But what if we wanted to use that salt to make another chemical? To use in a chemical reaction to, let's say, make a pharmaceutical, to make a drug for someone. Oh. Well, in that case, we would want to buy laboratory-grade sodium chloride, which is salt. So, you see, here's the problem. Even what appears to be a pure substance can have impurities in it. And those may be just single atoms or molecules of some other substance. So, that's not an issue if you're eating it. As a matter of fact, the USDA actually has an allowance for things like rat and mouse hairs in flour. Ooh, yeah, you've eaten them. But if we're using a chemical to make, let's say, a pharmaceutical drug, a cancer-fighting drug, a drug for asthma, a drug to help control high blood pressure or high cholesterol, having even one or two atoms or molecules that aren't supposed to be there can cause unanticipated side effects. So, we have to rate chemicals based on their level of purity. And the least pure would be things that are called industrial chemicals. These are things that are going to get dumped into sort of big vats and mixed. Road salt is actually basically industrial grade. It's not pure at all. It may have all sorts of contamination in it. Actually, maybe that's less than industrial grade. But if we want something that is absolutely pure, that we can pretty much guarantee doesn't have even a single atom or molecule of any other substance in it, no impurities whatsoever, we're going to look to purchase what are called primary grade reagents, sometimes reactant grade chemicals. So when we look back here, this is laboratory or reactant grade sodium chloride. This might actually even be industrial grade. I mean, we can see some little impurities here. The stuff that you and I eat on an everyday basis falls somewhere in the middle. Food grade is not as pure as reactant grade or laboratory grade chemicals because our bodies can tolerate some of those impurities. If we're using a chemical to affect a biological system, in some cases the biological system can't. What's interesting is that in many cases, the purification process used to create reactant grade chemicals is very similar to some of the processes that you have learned here in this lab. Okay, we'll stop our conversation there. There's an article for you to read, linked on Classroom. Have a good day.